Good afternoon, it's Jeremy. It's Wednesday, May the 21st. Over the past several months, I've been working on receiving CubeSat from university and various educational institutions. These are LEO satellites that go above the Earth between, let's say, 500 and 800 kilometers. The first month it took me to get together the hardware, consisting of an LNA, a bandpass filter, and hooking that up with the RTL. I've tried various antennas. I used the V-dipole, which I used receiving NOAA down at 137 megahertz. I found with the V-dipole, it has a wide capture range, which is good. It's very portable. The problem is it doesn't have enough gain at 433 megahertz. So what I've settled on here is I have an ATSC antenna, which I use in my apartment to receive UHF signals, TV signals from the CN tower. So what I've done is it's on a rotatable pole here, wooden pole. So I'm pointed at due east. My balcony looks due east. I'm surrounded by steel condos, so I have a very limited view. But I found with the UHF Yagi tied up with you need an SMA, of course, to CATV connector to get on here. There's the bandpass filter, and there's the LNA, and there's the RTL. So that setup seems to work quite well for me. Like I said, I tried the V-dipole. You can see signals with the V-dipole, but they're just not strong enough to decode. In Montreal, I found a really good location on top of Mount Royal, fantastic location, no QRM. But here in Toronto, there's a lot of QRM. But fortunately, the CubeSat that I started off trying to receive, the EIR-SAT-1, I finally pretty well received that quite well now, and I'm going to try and get some other ones, but that was the one I started off with, and I've been successful with that. I'm just looking at the blog post here. Here's a little bit of an updated diagram of what I'm doing. There's the Yagi, and there's the University CubeSat coming in there. There's the equipment, bandpass filter, LNA, and the RTL. I'm using SDR Sharp, and what I'm doing is not trying to record it live, but I'm using a baseband IQ recorder. So I tune the SDR Sharp 20 kilohertz below what I expect to receive, and I'll talk about that in a minute. That's for Doppler shift. And I sample up the lowest rate on the RTL setting, which is 250 kilosamples per second. The reason I do that is so that the IQ file doesn't get too big. And then when I've recorded the wave file, what I do is I play it back and I detect the received packets. Now they're going to be at different frequencies. The nominal frequency, let's say for EIR-SAT, is 437.1, but when it's coming towards you, there's Doppler shift, so it'll be above that in frequency, and when it's broadside of you, it'll be on frequency, and when it's going away, it'll be less. So what I do is I play the file back and I determine what the frequencies are. I pick the strongest packet, and then I feed it into GNU Radio, and I use EA4 GPZs out of tree module GR satellites to decode it. So that's basically the procedure there. The baseband files are quite big, so what I do is I put them, once I detect where the good pulses are, I put them in Audacity and I cut them down. Let's look at, yesterday I received a really good pulse on May the 20th. So let's look at the setup here. So I've got our SDR Sharp. I've tuned it at 437.08. And here's my baseband file player. Now I know that the strong pulse is down here. So I'll play the file and we'll see it. I've recorded it already. But let's go down here. That's the nice thing about this recorder. You can pick where you want. So it's going to be down there about. So let's start there. You'll see 5 discrete tones, then the Gaussian pulse, and then 5 more discrete tones. So basically this is, I start recording the minute I see the satellite footprint at my location. I start recording, and it's a big file, like I said, it's about 5 to 6 minutes long. And then when I find the pulse that's really strong, I cut it down with Audacity, and then I feed it into GNU Radio. So here's GNU Radio. Now, when you determine the frequency of that particular pulse, in my particular case, it was, let's go back here, it turned out to be, I think, 437.0976. Here, if you adjust this, what you can do is you can go after the fact and tune in tune in. So this red line here, the center line, is at the middle of the one of the center discrete pulse there, discrete carrier there, and then you can determine where it is. So I set the in previous videos and blog posts, I've described this schematic here. This is a schematic from EA4GPZ. He has a whole tutorial on how he came up with this. It's pretty amazing. So I set the frequency translating filter. This takes the IQ files and brings them down to baseband. So the difference between 437.080 and 437.0976 is 17.6 kilohertz. And then I see if I can get a dump here, a hex dump. So let's run this and we'll see. So there's my GUI time sync. And we'll go down here. There's the whole 250 kilohertz baseband. And what happens is when the received pulse comes in here, you'll see the 5 discrete lines there. Then you'll see the Gaussian pulse, and then you'll get a hex dump. So we might have to wait for a minute or two until that happens. Okay, there's the discrete lines. That was the Gaussian pulse, and then you see we got a hex dump here. So that pulse worked out well. So it tells you verbose PDU debug print, 9.6 K GMSK, 892 bytes. So then just in summary then, my procedure is I only pick satellites that pass to the east. There's 3 satellite databases which I use. I use NTYO. NTYO, you can predict 10 days in advance what it's going to look like. So I like passes that look like this. They're totally to the east. My Yagi's pointing east. And I like the slant range to be less than 1,000 kilometers, because that way I'll be able to decode the signal. So that's the first thing I look at. The SatNogs database gives you more information about the particular satellite. It tells you the frequency. It also tells you if anybody's currently receiving data, which is a good sign. If nobody's receiving any data, maybe something happened to the satellite. And finally, I use gpredict. And when the satellite footprint comes into my location, the minute that happens, the elevation is 0.0 degrees. I switch on the baseband recorders. So that's kind of my procedure then. I look for paths, satellite paths that are to the east, and I switch on the baseband recorder when they come into the footprint, and I set the frequency about 20 kilohertz below. I find out what the Doppler shift is, and I set it up in GNU Radio. So that's basically what I've learned over the past couple of months, and it seems to be working.